My name is Michael Hausenblas. I'm Chief Data Engineer at MapRTechnologies. What we do is we provide a big data platform, and we have a couple of ecosystem components there that we typically use to realize applications. That can be PageBase, Hive, Mahout, and others. And amongst that, I'm talking about two, and that is Solr and a bit of Mahout. So the scary part in the beginning. So later on, I hope to show you a live demo, which will then be scary for me, but now it's a bit scary for you. So I assume most of you know or recognize machine learning when they see it. It might look like that, right? Recommendations, like on Amazon or wherever, spatial recommendations. Even the little in spam in Google Mail, right? That's at the end of the day based on machine learning techniques. Under the hood, it looks a bit more scary. And as I'm a data engineer, I have my colleagues like Ted Dunning who have bigger brains, and they can deal with that. I'm just putting together the things and trying to make our customers happy. But that's how it essentially looks under the hood. Now, when you've been around 10, 20 minutes early on in this room, you might have heard Grant already talking about the applications of deploying, or at least scratching the surface a bit, deploying Solr as a recommendation engine. So what are the basic things there that we need? We have interactions between people, we call them users, and certain items. That items could be pretty much everything. That can be a book, it can be a song, and actually the demo I'm gonna show to you is about songs and artists and so on. And that serves as an input data for our model. And obviously the goal would then be to suggest or recommend appropriate or desirable interactions with that item. So for example, if I go there to Amazon, I get this wonderful, other people have also bought this in this box, for example. Probably even more interesting, as also highlighted by Grant early on, are these geospatial recommendations. If you can contextualize them, not only telling someone, pretty much everyone in Dublin goes to the Guinness brewery, right? For that, I don't need a very sophisticated algorithm. I just send people there because that's well known. But when I'm somewhere where I have probably less knowledge about the environment or whatever, I might depend on previous observations of where people spend a lot of time or interacted with certain items. As I said, the example applications include, but are not limited to, recommending similar movies, music, books, and so on. But also, if you think about the case shown here, suggesting a certain restaurant based on not only your preferences, but also maybe what your friends or your colleagues chose early on. One part where we actually deployed it at the customer, I'm going to show that at the end, is actually the interaction between a merchant and a customer, being able to suggest items there based on the history and also what the crowd essentially did early on. Talking about which. So the idea would be to derive from observing the crowd, so that should be a rather large population, to understand and predict or recommend what a certain individual will do. Let's have a look at that. So Alice, she got an apple and a puppy. And Charles got a bicycle. Now, obviously in a real-world setup, that wouldn't be 2 users, that would be 100,000 users, hopefully. Now Bob got an apple as well. So what else would Bob like? Any ideas? I know it's late, everyone is looking forward to the party, but...
Could be Bob. Could
puppy, of course. Bob likes puppies. So you get the idea, right? Very simple. You, well, at least in theory, it's very simple. You look at what other people did or what other people bought or viewed or whatever, and you're trying to come up with something sensible that in this context might make sense. Right. So now we have the pony case, right? Nothing against ponies. I like ponies. But if everyone got a pony, what would you recommend for Amelia? Well, of course, that's pretty much the same as with the welcome message at the if you're signing up at the social network. Everyone follows, I don't know, F on medium.com or whatever. So this kind of everything recommended to everybody is not really very interesting. So here we come to this concept already earlier introduced by Grant around co-occurrence of items. So as already mentioned, these very popular items, they occur with everything else. So that's not very interesting, right? What we're really interested in, and I'll dig a bit deeper in the following slides, are these anomalous co-occurrences. So things, so we need the indicators for that, and they essentially provide the basis for the recommendation. And there are some terms, I'm going to walk you through that in more detail that we need for that. That's the history matrix, typically derived from the log. And what we want to build is an indicator matrix, right? So that's what we can then feed into Solr and then drive our recommendation with that. And one term that occurs over and over again, and I believe Grant mentioned it earlier as well, is this log likelihood ratio, LLR, and there is a Apache Mahout module that takes care of that. So let's have a look at log files. Again, a couple of users that have seen, interacted, or whatever with a number of things. A bit more abstract representation users, and obviously what we really will have are some tables that will, dimension tables that essentially will tell us more about the users and things, but this is really the core we're interested in, right? User 1 has seen or interacted with thing 1. So, what we can do then is build up this history matrix, right? We sort of neglect or forget about the time dimension, so that Alice might have seen first the apple and then the puppy. The only thing we remember or capture is what items has Alice seen. And Bob and Charles and 999,000 more of these users. And if we transform this history matrix into a matrix that connects things by things, so the co-occurrence matrix through the LLR, we end up in things like that. So puppy and apple once. Puppy and pony once, pony and apple twice, and so on and so forth. The question now is how to tell which of these co-occurrences, so items that occur together, is really interesting, because only that we can use as an input or basis for the recommendation. So what you can do there is essentially reducing that to this binary matrix, essentially saying when a certain thing occurs with another one or not, so with anything else, with the pony and whatnot. And you record that essentially. Now here are 4 examples, and again, this is a bit of an interactive part. If you look at that, which one would you say is the interesting one? Where's the anomaly? Any ideas? Any takers? Come on, you gotta earn your Guinness. Okay, so as I said, through this log likelihood ratio, you can come up with these numbers. Actually, it's the square root of the LLR. And if you look at these things, well, let's step back a bit, maybe. Here, essentially, in the upper left corner, the item B occurred together with item A 13 times and not with A 1,000 times. So that doesn't look very interesting, right? In this case, well, it looks good, but we have too few data points to tell really if it's interesting or not. Here's a similar case, a bit more data points, but still the co-occurrence doesn't really tell me a lot. In this case, this essentially means they always co-occurred, right? Out of these 100,000, right? And that's essentially what this number means, right? Here, that's the highest one, so that's the really interesting part. Now, as I said early on, from this history matrix over the co-occurrence matrix, we want to derive or compute the indicator matrix. And essentially, that's the only thing we really record here. And essentially, what we want to capture and use as an input for Solr then are these significant co-occurrences, which are the indicators. And how that practically looks like, if you think about the document here, right? We take one row of this indicator matrix and actually add it as a field directly into the document, right? That sounds easy. Turns out it is easy. And you don't need a separate index or whatever for it. You can directly add it, and I'm going to show it in the demo, directly add it into the document that you have in Solr. All right, demo time. Fingers crossed. So, thanks to our colleagues from LucidWorks, we have, probably should first mention what this demo is about, right? So this is, as mentioned earlier already, or hinted at, a kind of music recommendation engine. So you have a number of things there. You know the albums, you know artists, and you know the tracks, right? These are the three things you know. So we can, for example, that's essentially the back end that you see here. Artists, let's search for Beatles. Beatles should always give something, and it looks like it works. And here we have, you know, the real Beatles. Do you see? Can you see that? I'm not entirely sure if you can see that. Right? Oops. Sorry for that. All right. So we have a name field there, an area, a gender. Okay, that's probably not very interesting here as a group, and certain indicator artists. And if we do the same for the albums, let's, for example, say this one. Right. Nothing. Let's go back to the artists then. Tools. So, oh, sorry. That doesn't really help me a lot, right? I need to go to the tracks and search for Heartbeat. Oh, come on. What other Beatles song do we know? Something with love, maybe? No. I knew it. I knew it. Wonderful. That's obviously a wonderful thing. Yeah. Probably too many dry runs. I'm sorry for that. No. Very sorry for that. I'm not gonna fix it now. Let's just see if I can still show you the front end. So what we essentially did there, what we colleagues, slap a bit of a front end onto that Solr deployment here. And I'm pretty sure, unless it's cached, it won't really work, but let's try it nevertheless. Okay. That might be cached though. So let's go for a certain album. Help. And imagine now that when I click this button here, what I'm actually doing, I'm playing the track, right? Whenever I'm playing the track, I, as the user, and this item, this example, the track 1 help, are interacting. And that's actually captured, right? And what I get here are recommended artists around that. That would be the output. Not very pretty though, but as you can imagine, yeah, you can make it more pretty, but at least as a proof of concept, it does its job, right? It works, and should at least give you a bit of an idea. So yeah, that was just in case the demo doesn't work at all. Essentially, going through these things step by step, and when these slides are shared later on, you can have a look at that yourself. However, I would actually encourage you to try it out yourself. So if you go there, this bit.ly, whatever link, that's a Google Docs drive that contains the entire, the architecture, everything you need, the data, everything. So you can really try it out yourself, deploy it, and play around with that to get a bit of a feeling how that works. Just see. So everything is here, and you see all the details there. Configuration, track data, everything there, right? Okay. Right. So that's a nice toy example. It serves at least to give you an idea how to go about that, how to set it up, how to use it in a certain domain. What I find probably a bit more interesting are real-world examples. And this one actually is one of our bigger customers where we've implemented and which is now in production, a search-based recommendation. So imagine the following. As earlier already hinted at, you have merchants that have certain, metadata attached, might be address, location, and so on and so forth. You've got these fields in the sample document that we derived or computed through the concurrence analysis. And a certain sample query might look like that. So as a user, I might have a app, or in this case it is an app, on my mobile device that allows me to track the current location. There's some knowledge about the recent merchant descriptions, IDs, SIGs, and whatnot. And that taken together allows me to provide the user who is using that app along with a transaction that might be, a credit card, for example, transaction, to come up with a very personalized and localized recommendation, right? So imagine you walk out in the evening in Dublin and you have this app and you buy something and you get a text message or in that app telling you, by the way, around the corner there is a shop that offers this whiskey you really like, or that you and your friends really like, for 20% off. Right? This kind of application is realized through that. And how did we do that? Well, essentially, pretty straightforward, obviously on MapR. Essentially building the occurrence metrics, taking complete history into account using Mahout, the LLR stuff, as you remember. Then we have the item metadata in the file system. This also drives a MapReduce job for the Solr indexing, and you have that index there. That's essentially the phase where everything is built up. And then in the serving phase, if you want, you come up with the concrete user histories or your interaction based on the app, the credit card transaction, and that can directly drive the web tier and come up with these recommendations, personalized and contextualized to your current situation. All right, and that was already pretty much it. Again, huge kudos to Ted and Grant, who did all the groundwork here really, and the LucidWork folks that provided the demo, although I managed to run it to the wall. If you want to get in touch with me, I'm around both days. Tomorrow there's another talk. And yeah, in case you're interested in, we're hiring. And now I'm open for discussion. So the question was, once you have the indicators calculated, how you integrate that with other things. So, as I said, it pretty much depends on, where does your data come from? There are requirements. So, let me give you a concrete example. If I'm running around with that app in my pocket, on my mobile, then there's only a very tiny window available for me to receive that recommendation or that ad or whatever. Which means these hard requirements, which is, can be considered as real time, means that the preparation phase as such needs to be decoupled essentially, and I need to be able to capture your contextual information, so the one customer and merchant, and whatever I need in the query, process that in real time. I mean, for a human walking around, probably a couple of minutes would still be considered okay, depending on the situation. But the key point really is that, as you see here, the hard part, the heavy lifting, is already done in this phase, right? So the complete history has already been processed and made available there in the system. And at this part, at this stage, in the serving phase, I only really take into account this rather limited user history. I give it to you that there are still challenges, right? How do you make sure that you get all your data in time and process it in time? The only thing I can tell you about this concrete deployment at the customer, that they got down the time from 20 hours pre-processing plus 8 hours ingestion down to 3 hours plus a couple of minutes to get the index over there. So relatively small. Right. So the question was, just need to repeat it for the recording and everything. Unfortunately, we don't. Oh, brilliant. Yeah. So the next question we can use the mic. That not all of the data is actually available. So part of the data will be only available at query time, right? Yes. So there are two things to that. On the one hand, obviously, so at least from a user perspective, I would expect that my personal preferences override. So that's a typical situation when I tell. I'm not going to call any names, but if I have a social media site and I say, don't notify me about this group of people, right? And then the output of the recommendation engine is, oh yeah, you should really be interested in these people. So I would expect that my personal preferences, and that could be, depending on, okay, I'm in my home country, so it's fine, or I'm abroad somewhere, so don't show me these things because it doesn't make sense. That those static user-defined preferences override the recommendation, right? Do you see that? I mean, do you agree with that, or is that something you would want the algorithm to take care of? Maybe, can we have the mic? It's right.
But the recommendations really are not taking into account where the person is who's doing the search, right?
Well, in this case, it does, right? The current location means the location of the user, right?
Yeah, but the indicator offers were generated without knowing where this particular user was, right?
No, sorry. The merchant has a certain location, right?
When you did the co-occurrence, you weren't conditioning that on any particular geographic factors. So the co-occurrence, as I understood it, was not location-based.
You mean in this example?
Well, when you went through the co-occurrence matrix before.
Oh, okay. So you might want to, take these. The one is the kind of toy example that just gives you an idea how things are working, and that's the real stuff. And here we take both into account, yes, obviously. Sorry. Any other questions? Yes, can you hand over the mic, please? Thank you.
So it seems this approach to collaborative filtering is quite reliant on the sparsity of this item-item co-occurrence matrix. I was wondering sort of how sparse that is and if you need to prune it. And also how this compares with sort of approaches that rely on dimensionality reduction instead of the sparsity.
To be honest, that's a bit beyond what I can tell you. What I can do, and I'm happy to do that, to capture that and put you in touch with Ted, who really has a very, very deep understanding. I wouldn't be able to come up with a sensible, quantifiable answer for that. So to really tell you to what percentage that impacts it or whatever.
Okay, no worries. It is a very neat trick, though, that you take advantage of the sparsity of this matrix and to index it using Lucene. Like in the previous talk, this idea that you can treat a Lucene index as just a big sparse matrix.
Right. And do you, just to get a better understanding, do you oppose this idea? Or
No, not at all. No, I'm just interested in the trade-offs. I guess maybe what I'm thinking is as you accumulate more and more co-occurrence data, this item-item co-occurrence matrix is going to become denser and denser as you accumulate more co-occurrences. But I'm presuming that you prune the entries in it.
So, again, I'm as a data engineer, I'm mainly looking at these things, right? But I give you that. There's the theory, and there is what you do out there. The only thing that I can tell you is that so far we haven't seen these problems in production. It is certainly interesting to figure, where would these problems occur? So to what, how dense can this metrics really become before we're running into this kind of problems? But yeah, from a theoretical point of view, again, that's a very good question. I'd love to discuss with Ted as well to see if there are, is Grant around? No, he's not around, right? He might have an idea as well. If there is an upper limit where you say, okay, from here on, don't use it anymore. I simply don't know.
I mean, I'm guessing if it gets too dense, you can always try pruning it, and that, just like setting.
Yes, but again, the question remains: when do you start pruning?
Yeah.
And that's something I simply can't answer. I don't know. I can tell you so far we have not run into that problems. And for the customer, at the end of the day, the main point was to reduce the 20 plus hours to 3 hours, and the ingestion from couple of hours to minutes, and being able to serve recommendations much faster and more interesting, more contextualized.
So one other quick question is, do you end up needing to rebuild the whole index, including the text, every time you want to learn a new co-occurrence matrix? Or can you kind of update that co-occurrence matrix separately to the text index?
I'm not entirely sure how it is currently done. I'm not involved in that. I believe it can be updated, but I'm not sure how it's exactly here in this situation done. It might well be that it's rebuilt, but I'm not in the loop currently. So again, very happy to follow up on that. Need to discuss with the people who are engaged with the customer currently. Thank you very much.